Hello, welcome to the video notes for lesson 10-6. This is the final lesson for topic 10, and this is about relating similar triangles and slope. This begins on page 32 from your notes packet. Let's take a look at the lesson target. I can use slopes of lines to compare and draw similar triangles. Now, you'll remember slope from earlier this year in our linear unit. The slope, remember, is, let me write this down, and you're going to want to write this down too. Slope of a line is the change in y over the change in x. Remember that this triangle symbol stands for delta, or which means change, or rise over run. Okay? So, the first example says graph the line y equals 3 over 2x minus 4. Draw two similar triangles on the line. Actually, we're going to draw 4 on the line. How do you know they are similar? Okay, so let me clear the screen, and I'll move this up so we can see it, and we've got plenty of workspace. Okay. Alright, so first let's do graphing the line, 3 over 2. So m, the slope, is 3 over 2. Rise is 3, slope is 2, or excuse me, the run is 2. The first thing we need is a point on this line. Well, remember, we can use our y-intercept, b equals -4. So you go on the y-axis, go down to -4, and put a point. Now, put more points by doing 3 over 2. So you go up 3 over 2, put a point. Up 3 over 2, put a point. Up 3 over 2, put a point. Up 3 over 2, point. And we run out of points that way. Let's go the other way. Down 3 and to the left 2. Negative, negative is a positive. Down 3, left 2, put a point, and we're done. Almost. We need to connect these points using our ruler or straight line tool. So I will do that with my line tool here. And don't forget, at the end of your, let me get it straight. I guess that's as good as it's going to get. At the ends of your line, put arrows because it continues on. Alright, so first point, or first triangle I'm going to do, we'll call it triangle A. And you know what? I'll pick, why don't I go from the y-intercept. I'm going to go up, I'll go from this point to this point. So I'll go over to the y-axis and down. This is my triangle A. So the change in y over the change in x is, so it's going up 9 and over 6, but that simplifies to, if I divide the top and the bottom by 3, 3 over 2. So the slope for this triangle is 3 over 2. Let's do another triangle. We'll call this triangle B. And let's make this one a little bit smaller. We'll go from this point to this point now. So I'll box it in, go down and over. So this is B. So since I went down, alright, so the change in y is this time -6. But I'm going left 4, the change in x. So that's -4. A negative over a negative is positive. Positive 3 over 2. Same slope. Okay, let's pick a different color here. We'll go, this time this is C. Let's do a little triangle. How about right here? This is triangle C, and, well, that one is, of course, change in y over change in x is 3 over 2. Notice that the slope of these is all the same. One more triangle, triangle D. We'll make this a super big one here. And let's go from the bottommost point all the way up to the topmost point, all the way over. Wow, that's a pretty big triangle. This triangle has a change in y of 18 and a change in x of 12. And when you simplify 18 over 12, you get, you guessed it, 3 over 2. So, all these triangles are similar because, well, if we were to find their, so one thing that we know is with triangles that are similar, they're the same shape, different sides. But if we want to be more specific, we can talk about how their side lengths are proportional. So we already knew this, but the side lengths are proportional. The side lengths are proportional. That will always be true. Oops, it's supposed to be proportion. But something else that you can say, so and, oops, slash or. Now we can also say if their slopes are the same, they are similar. And or the slopes are the same. So if you want to prove that triangles are similar, find their side lengths and see if they're proportional, or if they have, if you can find the slope of the common, side, the corresponding side, I should say, which is along this line here. If the slopes are the same, then they must be proportional. All right, so let's take a look at an example of this over on the next page. So now we're looking at page 33. Given triangle JKL is similar to PQR, find possible coordinates for R. So they gave us PQ, they did not give us R. Remember, the triangle that we're creating is going to be similar. So one thing we can tell just by looking at this triangle, we can find the slope of this side here. And that's the slope we want to recreate. So change in y over change in x. So let me use a different color here so it's easier to see. So change in y, I'm going to go from L to J, is going up 6 spaces. And it's going over 4. 6 over 4 simplifies to 3 over 2. So we're looking for a slope of 3 over 2. All right. Well, if I were to go, so I'm at this point P, I need to find R. Remember, it's going to be a rise of 3 and a run of 2. Why don't I go backwards and go to the side 2 spaces and then down 3. So 1, 2, down 3, put a dot. That could be R right there. Or I could go over to down 3. That could be R, because either way, oops, let me keep my color coordinated here. Either way, no matter which point I use, the slope is going to be 1, 2, 3, 1, 2, 3 over 2. So the possibilities are, R could be 1, 0, or R could be 5, 0. Okay? Now, something else to point out here. If I'm looking at this side PQ, this side right here, the side length for that is 3. Now this corresponds to this side length here, JK. Now JK is equal to 6. So what's the scale factor going from the original image to the original figure to the image over here, it's going from 6 to 3, which is 1/2. All right? I can also compare these sides down here just to make sure that either point R would work. So this side, LK, on the original figure, is 4. Well, this side, QR, whether I go this way or go this way, is going to be QR. It's going to be equal to 2. So does the scale factor of 1/2 work? Yes, it does. So this confirms it. So by using the slope, you can identify your missing point. It's either on this side or this side. So there's 2 possible answers for this. And yes, I know that's probably going to bother some people, but all right. So is triangle MNO similar to triangle PQO? Now, some of you remember in class we talked about we don't like to use a letter for 2 different points. Point O is the same for both of these, so it's okay if we have O twice, up here and up here. If there was another point labeled O, that would not be a good thing. So, but it isn't in this case. All right, so I'm going to let you finish this on your own. To tell if they're similar, you either need to show that the sides are proportional, or that the slopes are the same. So, see if you can find either the side lengths that correspond and show that they're proportional, or find the slopes, that would be these diagonal lines here, and see if they are the same. If you don't know how to do that, just try something. We'll go over this in class together, and I think you'll understand it nicely. So if you had any trouble, go back and rewatch the video, or come see me for help. Good luck, and we'll see you in math.